Okay, so good afternoon to all the students. We will continue yesterday lecture that is a basic fundamental of thermodynamics law. So let's start the lecture. Okay, students. So you are here to see that these are the process: adiabatic process, isothermal process, isobaric process, and isochronic process. Okay, so we're going to study in detail in this process one by one. Okay, so adiabatic process is that there is no heat transfer. Okay, let's start this process. What is this process and what is the application of this process? Adiabatic process, yes, and adiabatic process is transfer no heat. There is Q equal to zero. Okay, there is Q equal to zero. So we know that the difference in the internal energy, the difference in the internal energy is equal to transfer heat minus work done. Okay, we know that the change in internal energy that is equal to transfer heat minus work done. Okay, so students, what we can do, we put Q equal to zero here. Then what happened? The change in internal energy is nothing but that is the work done, that is the work done in the reverse direction. Okay, when a system expand adiabatically, W is positive. W is positive. Okay, then system does work. So change in internal energy that is the delta U is negative. So here, like this formula, like this formula, what can we do? If Q equal to zero, then what is here we can done? See, delta U equal to delta U equal to what is minus W. But what this statement say that when a system expand adiabatically, then what is the meaning? Work done is positive. So if work done is, if in this equation work done is positive, then what is the negative? We put the work done positive. We put the work done positive. So W equal to minus delta U. That is the mathematical formula. That is the mathematical formula. Okay. So we can say that work done is positive, but change in internal energy that is the negative. When a process compress, so when a process compressed adiabatically, W is negative. Okay, so this is the for the extension will expand. Then the work done is positive, and when it's compressed, then it is the negative sign. Work done is negative. Okay, Now, the next process is isothermal process. And what is the isothermal process now? An isothermal process is a constant temperature process. Means what happen? The temperature of the object is remain constant. Okay. For example, if we're going to do a process on a 30 degrees Celsius water, then the water temperature after the work, after the process is remains 30 degree. There is no change in the water temperature. Okay, like what is the process of this type? Like a 0 degree ice converted to the 0 degree water. Okay, the water temperature and ice temperature is same, but process is done. Heat is added. Okay, the process is done, but heat is added. What is the amount of heat added? That is, we call the latent heat. That we call the latent heat. Okay, because a 0 degree ice converted to the 0 degree water, then what do we? Some heat amount is added. That's why the solid phase converted to the liquid phase. Solid phase converted to the liquid phase. But the temperature is same, but the temperature is same, so meaning is that there is the process is on the constant temperature. Okay, any heat flow into or out of the system must be so enough to maintain the thermal equilibrium. For example, ideal gas, if delta T is the zero, delta U equal to zero, then therefore whatever the heat transfer, that is the work done. Okay, any energy entering the system Q must be leave at the work. Okay, whatever if the temperature difference is zero, so internal energy change in internal energy also is zero. So whatever the heat we apply, whatever the heat is utilized on the process, that is equal to work done. So next is isobaric process. What is the isobaric process? And isobaric process is a constant pressure process. Delta U, W, and Q are generally non-zero. So means change in internal energy is not zero, work done is not zero, and Q is not zero. Okay, but calculating the work done by ideal gas formula, W equal to P into delta V. Okay, for example, water boiling in a saucepan is an example of isobaric process. Okay, the pressure is not changes. Isobaric process is the pressure is constant. For the example, boiling water in a saucepan, that is the example of this isobaric process. Isochronic process, what is that? Isochronic process is a constant volume process when the volume of a system doesn't change. It will do not work on its surrounding. W is equal to zero means W work is zero. Heat gas is closed container. Heating a gas in closed container is a isobaric process. Okay. Now, what is the heat capacity? The amount of the heat required to rise a certain mass of material. Heat capacity. What is the heat capacity? The heat capacity is nothing but the amount of required heat required to rise a certain mass of material by a certain temperature is called the heat capacity. That is heat capacity of a system Q equal to mcx delta T, where Cx is the constant, that is called the specific heat. Cx is the specific heat of substance X. Okay, and you know what is the delta T, temperature difference, and Q is the heat transfer. Okay, so student, just 1 minute. I want to show you something. So students, I show you a video which is very useful to understand what is the adiabatic process. So student, you go to this video, that is the adiabatic process. In this video, the explanation of adiabatic process is shown in animation, so you can see.
कि ये एक ऐसा थर्मोडायनामिक प्रोसेस है जिसमें हीट में बात करेंगे कि ये एक ऐसा थर्मोडायनामिक प्रोसेस है जिसमें हीट या मास का ट्रांसफ़र नहीं होता सिस्टम और सराउंडिंग में। जैसे कि हम जानते हैं कि थर्मोडायनामिक प्रोसेस हीट एनर्जी और दूसरे फॉर्म्स की एनर्जी के साथ रिलेशनशिप से ताल्लुक़ रखता है। फॉर एग्ज़ाम्पल, अगर हम किसी सिस्टम को हीट देते हैं तो हीट देने से उस सिस्टम में जो मूवेबल पिस्टन है वो अप हो जाता है, मतलब कि हीट एनर्जी ट्रांसफ़र होती है मैकेनिकल एनर्जी में। अगर हम उसी मूवेबल पिस्टन पर एक्सटर्नली वर्क करें चेंज नहीं होता सिस्टम और सराउंडिंग के दरमियान, मतलब कि हीट ज़ीरो होता है। सिस्टम को ना ही हीट दी जाती है, ना ही सिस्टम से हीट को बाहर निकाला जाता है। फिर भी ये एक थर्मोडायनामिक प्रोसेस है। तो वो कैसे है, चलिए इस वीडियो में देखते हैं। एडियाबेटिक प्रोसेस में एडियाबेटिक एक्सपेंशन भी होता है और एडियाबेटिक कॉन्ट्रैक्शन भी होता है, पर हीट को एक्सचेंज नहीं किया जाता। एडियाबेटिक एक्सपेंशन में एक कंटेनर लिया जाता है जो कि इंसुलेटेड कंटेनर हो, जिसमें से हीट ना ही अंदर जा सके ना ही बाहर आ सके। तो उसका जो मूवेबल पिस्टन होता है उस पर से एकदम से जब लोड हटाया जाता है तो वो पिस्टन अपवर्ड मूव करता है। मतलब कि कंटेनर का वॉल्यूम इंक्रीज हो जाता है, बढ़ जाता है, और कंटेनर का प्रेशर कम हो जाता है। तो इस कंडीशन में कंटेनर के अंदर का जो टेम्परेचर है वो भी कम हो जाता है। बाहर से कोई भी एक्सचेंज नहीं हुआ हीट का, और उस सिस्टम की इंटरनल एनर्जी नेगेटिव हो जाती है। और अगर हम एडियाबैटिक कॉन्ट्रैक्शन की बात करें तो उसमें एकदम से उस पिस्टन पर लोड बढ़ाया जाता है, तो पिस्टन नीचे की तरफ मूव करता है। उस कंडीशन में वॉल्यूम डिक्रीज हो जाता है, कम हो जाता है, और प्रेशर बढ़ जाता है। प्रेशर बढ़ने की वजह से टेम्परेचर भी इंक्रीज हो जाता है, और जो इंटरनल एनर्जी है उस सिस्टम की वो भी।
So, students, as you see in this video, what happened? This process is expansion process, and this process is construction process or compression process. Okay. So, in this process, what happened? The system is extended. Okay. So, whatever the change in internal energy, that is the negative, and here the compression or construction is there. So, here the volume is reduced. The volume is reduced, and the change in internal energy, that is the positive. Okay, so continue.
बढ़ जाती है, जिसको हम पॉजिटिव कह सकते हैं। जब एडियाबैटिक एक्सपेंशन होती है तो उस कंडीशन में जो वर्क होता है वो सिस्टम वर्क करता है, क्योंकि जो सिस्टम में गैस है वो पिस्टन को अपवर्ड मूव करवाने में मदद करती है, तो इसीलिए वर्क पॉजिटिव होता है। और एडियाबैटिक कॉन्ट्रैक्शन में सिस्टम पर वर्क किया जाता है, मतलब लोड को बढ़ाया जाता है, तो उस कंडीशन में वर्क जो है वो नेगेटिव होता है। अगर हम एडियाबैटिक प्रोसेस की इक्वेशन को ड्राइव करें फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स के मदद से, तो हम ये कह सकते हैं कि Q इज इक्वल्स टू ज़ीरो, क्योंकि बाहर से कोई भी हीट आ नहीं रही, ना ही अंदर से कोई भी हीट बाहर जा रही है। तो फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स की इक्वेशन में Q को ज़ीरो रखेंगे, तो ज़ीरो इज इक्वल्स टू डब्ल्यू प्लस डेल्टा यू। तो ये इक्वेशन बन जाएगी W इज इक्वल्स टू माइनस डेल्टा यू। मतलब कि अगर वर्क पॉजिटिव है तो इंटरनल एनर्जी कम हो जाएगी। जब एडियाबैटिक एक्सपेंशन होती है जिसमें सिस्टम वर्क करता है, उस कंडीशन में हमारी जो इक्वेशन बनती है वो बनती है वर्क इज इक्वल्स टू माइनस डेल्टा यू, मतलब कि इंटरनल एनर्जी कम हुई है। पर अगर हम बात करें एडियाबैटिक कॉन्ट्रैक्शन की जिसमें सिस्टम पर वर्क किया जाता है, तो उस कंडीशन में इक्वेशन बनती है माइनस डब्ल्यू इज इक्वल्स टू प्लस डेल्टा यू, मतलब कि वर्क जो है वो नेगेटिव है, पर जो इंटरनल एनर्जी है वो बढ़ गई है सिस्टम की, क्योंकि प्रेशर बढ़ गया है। एडियाबैटिक एक्सपेंशन में पीवी कर्व डाउनवर्ड होता है, मतलब कि प्रेशर कम होता जाता है और वॉल्यूम बढ़ता जाता है, और जो टेम्परेचर इनिशियल था उससे टेम्परेचर फाइनल जो है वो डिक्रीज हो जाता है, क्योंकि यहाँ पर इंटरनल एनर्जी नेगेटिव है, मतलब कि उसकी जो इंटरनल एनर्जी है उसका इंटरनल टेम्परेचर है वो कम हो गया है, क्योंकि वॉल्यूम बढ़ गया है और प्रेशर कम हो गया है। पर अगर हम एडियाबैटिक कॉन्ट्रैक्शन की बात करें तो उसमें पीवी डायग्राम या पीवी कर्व जो होता है वो अपवर्ड होता है, और जो टेम्परेचर इनिशियली था उससे टेम्परेचर बढ़ जाता है, क्योंकि यहाँ पर जो इंटरनल एनर्जी है वो ज़्यादा है, प्रेशर बढ़ गया है और वॉल्यूम कम हो गया है, तो ज़ाहिर बात है टेम्परेचर भी बढ़ेगा। आई होप कि आपको एडियाबैटिक प्रोसेस समझ में आया होगा, और इस एडियाबैटिक उम्मीद है कि आपको एडियाबैटिक प्रोसेस समझ में आया। बिस्मिल्लाहिर्रहमानिर्रहीम, अस्सलाम वालेकुम। आज हम इस वीडियो में प्रोग्रामिंग के बारे में बात करेंगे।
Okay, student. So you can see the animated things of version of adiabatic process. So now you can understand what is the adiabatic process, because adiabatic process is very much important. Okay, that's why I show you in a in a video form. Okay, just 1 minute. I will again share my slides. Okay. So adiabatic process is very much important process. In this process, what we can see, what we can understand that the work done on system and work get from the system. Okay, there is two things. When system is extended, then the meaning is work get from the system, and when the system is compressed, meaning is that work done on the system. Okay, so when work done on the system, it means work is negative. Sorry, work is negative because we give the effort, then this is the negative. We lost our energy to provide the pressure on the system. So that is the negative work. And when system is extended, then work taken from the system. So the change in internal energy in this case negative, but work is positive. Okay. Okay. So the second law of thermodynamics is now we're going to study what is it that thinking about you can't break the even. Okay. So think about it means to not break the even. Every effort you put forth, no matter how efficient you are, will have a tiny bit of the wastage. Means what is the purpose? What is the meaning of that? कि if you are so much experience, so much effort doing any process, but you not convert it 100%. Means whatever the input you apply, all the input is not converted to the output. That is the that is the universal law. You can't break the event. Okay, a tiny bit is wastage is there. Means energy loss is there. When we apply some energy to do in work, then some energy must be waste. We can't utilize all the energy or all the input whatever we give the input, and we can't convert all these input to the 100% work done. Okay, the second law can also be stated that heat flows exponentially from a hot object to cold object. Means what happens? The rule, if we do not taking any external effort, so the what is the natural flow? The heat is always flow from hot one to cold one. Means if T1 and T2, there is two objects. The temperature of a object is T1 and the another object is T2. Then if T1 is greater than T2, if T1 is greater than T2, the meaning is that the heat flow from A object to B object, from T1 to T2 until T1, T2 equal to each other. Like see, T1 and T2. T1 is hot, T1 is hot and T2 is cold. Then what happened? Heat flow always from T1 to T2. heat flow always from T1 to T2 until T1 equal to T2. Okay. The exact of a useful thermodynamics variable called the entropy, we represented by S. Represented by S. Okay, called the entropy, a natural process that started in one equilibrium state and in another equilibrium state in the direction that causes the entropy of the system plus environment to the increase for an irreversible process, and it to remains constant for the reversible process. Okay, so SF equal to SI. If this is will be happen, then the meaning of that this is the reversible process. If SF means final entropy and the initial entropy is greater than, if the initial entropy is less than from the final entropy, then this is the reversible process, irreversible process. So in this case, the process can't be reversed. But in this case, when the final entropy equal to initial entropy, that is the reversible process. So we can reverse that. So for the example of the reversible process, for the example of the reversible process, that is the ice converted to the water and water is also converted to ice. That is the reversible process. Okay, we can reverse the process. We can easily make the make the ice from the water and ice to water. Okay, but the example of the irreversible process is we can make the curd from the milk. This is the irreversible process. We can't convert the curd to the milk. Okay, this is the one directional process, or we can say that this is the irreversible process. Okay, students. So next, the second law of thermodynamics introduced the notion of the entropy S, and the measure of system disorder. U is the quantity of the system energy and S is the quantity of system energy, another energy. Okay, so there is two system. One system energy is capital U and other system energy is S. So another CP, snow, the expansion process. Not knowing the second law of thermodynamics is the culture, equivalent to the never having the read Shakespeare. This is the example like that. Okay, what is the implementation of the second law? Time time marches on. If you watch a movie, how do you know that you are seeing event in the order they occupy? So sorry. Okay, if a drop of raw egg on the floor, it becomes extremely disordered. Greater entropy is there. Playing the movie in the reverse would show pieces coming together from a whole egg, decreasing entropy. So there is the example of the egg. When egg is piled down on the floor, then this is the great entropy, means entropy is higher, and when it's reverse, so the pieces coming together from a whole egg, decreasing entropy, means when we boil the egg and cut into the pieces, cut into the pieces, and then we throw them. This is the example of entropy is reduced or entropy is decreased. Okay. Direction of a process. Second law. Second law helps determine the preferred direction of a process. A reversible process is one which can change state and then return to the original state. That is the reversible process. This is a idealized condition. All real processes are irreversible. Okay, all real is irreversible. Okay, means what happened? A hot tea in the room, a hot tea in the room, it is always that the heat transfer from the tea to environment, because the temperature of environment is less than hot tea. Okay, it is not possible that hot tea gets the heat from the environment. This is not possible. So this is the irreversible process. So we know the direction when a hot cup tea is put on the table in a room. Then this is always that the heat is transferred from the tea to environment. Okay. Now, what is the heat engine? Heat engine is an equipment which is work on the second law of thermodynamics. A device which is transform heat into the work is called the heat engine. A device which is transform the heat into the work. Okay, this happen in a cyclic process. A heat engine requires a hot reservoir to supply the energy QH and a cold reservoir to take the excess heat QC. Okay, so the heat engine, what is that? There is a source, there is a source which is release the heat. In the heat engine, what happened? There is a source which is release the heat. के पास बोतल रहेगी टिफिन ही नहीं आया ना आज अरे उड़ी थिएटर पर देशमुख सर ने बुला लिया कि एल्यूमिनियम से उधर बैठे फिर लिस्टर का टाइम हो गया फिर सीधा आएंगे Okay, student. So, heat engine is a device which is convert the heat into the useful work. Okay, so the meaning is that in the heat engine, there is a heat source which is produce the heat, and this there is a heat receiver which is absorb the heat. Okay, so the system which is increase or produce the heat, that is the QH, and another is QC. So QH is defined as a positive and QC is defined as a negative, because QH generate the heat and QC receive the heat. What is the cycle? It is beyond the scope of the